Hi, X16 fans. It's time for another update on the assembly environment for the Commander X16. Other changes have been taking place in the X16 world. I've heard that the hardware prototype number 2 is being worked on. We recently had a release of a new kernel and emulator to bring it up to R38. And of course, I've got lots of changes on the assembly environment, which is why we're here. 2020 is going to be marked as a year of changes, that's for sure. We still have, as of this date in October, we have the pandemic is still going on. We're all wearing lots of masks. I think the entire West Coast is on fire. And we've got murder hornets. Not in my yard, but I know they're around. And I'm not even going to talk about the election. One change is that this video is going up on a channel dedicated to X16 work and or other retro projects that I might get involved in the future. But before we get into that, I'd like to show you something interesting. While I'm programming, I either watch YouTube videos or this last week I've been watching Netflix videos, and one of the shows I was watching was *Halt and Catch Fire*, which, if you haven't seen it, it's kind of fun. It's a dramatization of the early days of some of the retro computing that happened in the early 80s. And let me just show you something interesting I saw there that's related to one of our favorite machines, the Commodore 64.
This first shot occurs from a scene during the second season of *Halt and Catch Fire*. The lead character is working on her terminal and she's working on a game. I always like to look at the code and see if it makes any sense in context. If you look at the second line in her code, you see what appears to be an MS-DOS path. That's all well and good until the camera backs off and I had to take a look at some of the other details. If you look closely at the reflection of the character in the screen, it looks like, to my eye, she's typing on a bread bin, a C64 bread bin. And there in the lower right hand corner, we can definitely see a Commodore disk. So the question I asked myself is, what's going on here? Why is she typing MS-DOS paths into a program using a Commodore machine? Doesn't quite make sense. And the C64 bread bin theory is definitely been verified with this scene from season 3, where you can see the Commodore 64 sitting there on her desk. So you have to ask the question, did the special effects and the set dressers know that they were producing some sort of weird combination, or does this character really love her C64 so much that she's built a terminal out of it? Either way, I was amused. It's a long ways from 0.4 to 0.8. The current release is feature complete. What that means is everything that we originally envisioned about a year ago is now in the system and working in one way or another. What we've got left to do is to polish the code, get rid of oddities, make it enabled so it could be ROM'd, and remove any bugs that we find between now and shipping. So here's the features that we have added to 0.8. One that's most important to me as a developer was to change from the less capable Acme assembler to the more flexible CC65 toolchain. This is the same one being used by the kernel and other ROM'd pieces of code. We added some usability functionality, the best of which is the ability to edit an instruction in place. The debug display now shows the pseudo registers in 0 page, which are R0 through R15, and you can't live without looking at the stack. Error messages are likewise improved. They stick around longer so you can read them, and there's more of them, and they're more precise. Finally, you have the ability to remove watch points when they're no longer needed. Important for development of your program is the ability to save the program to a text file. This is very useful when you're ready to move out of this environment and start using a more traditional tool chain or some other type of development environment. Finally, the ROM and the emulator were just recently released to be R38 with important support for the SD card, so we now support that. And in fact, the assembly environment actually requires R38. In the previous release, version 0.7.2, I did a live demo creating a Hello World program. This time, I'm also going to create a Hello World program, except in this case, we're going to be writing to the disk and exercising that all-important SD card interface in the kernel. Okay, this is the fun part. This is where we get to do some coding. First, I'll turn on the mouse so I have the ability to point things out to you. That's not something that you need to do while you're developing. Then load the development environment, which, if according to plan, will be the last release that we need to load this into RAM. I'm going to start out with the skeleton program, just like we did in Hello World. Okay. So I always like to bracket my program with some sort of input, sort of output, so that I know that it's working correctly. And for these programs, I'll clear the screen, and then when it's finished, I'll print out done. So let's go ahead and throw that in there right now. Okay, there, how is it? Clear the screen, load up R0 with the address of the done string, call print, and then exit. Looks pretty good. Let's give it a shot and see how it runs. Okay, it printed out done, but it didn't clear the screen. So what's wrong with that? I see I used the wrong character. I should have done 93 instead of 94. So back to assembly we go. We'll use in-place editing to change that 94 to a 93. Then let's try and run it and see how it works. Great. That's exactly what I was looking for. So now let's get down to the business of actually creating a file. When you're working with the kernel, there's 3 steps. There's telling the kernel what the name of the file is and your read-write mode. There's telling it where it is, which disk, and then there's actually opening it. So we'll go ahead and implement the file opening code. Okay, how did we do here? Well, we load up the pointer to the file name and give it a length of 12, or B in this case, if you count the characters, test.txt, S, W, which is sequence file write mode. That's 12 characters. And then we tell the kernel that's the name of our file. A logical file of 4 on disk 8, secondary logical 4. And we tell the kernel that's where the file is to exist. We go ahead and open it, and then we change our output to a logical file 4, and then I still need to print the string into the file. open will return carry equal 1 if there's an error, and we'll add some error handling in a minute, but I'd like to get the straightforward path of writing the data out. So let's go ahead, we'll write the data to the file and then close it when we're done. What's this looking like now? Load up the address of test string into R0, call print. Then, when we're done, tell the system to close the logical file 4. That's really important so that it'll flush if it has any buffered contents, it'll get flushed out to disk. And then, equally important, let's change our output back to logical file 3, which is a screen, so that the print string will actually work. Now, about that error handling. Back on the open, if there is an error, a carry will be set. So we need to add an error handler to let us know if something went wrong during the open. Let's go ahead and add that. Now, if there's an error, the carry is set, the code will vector down to the error handler, which loads the address of the error string into R0 and prints it out and then returns from the main program. That looks pretty good. Okay, so it ran, but my data didn't go out to the file, it went out to the screen. So something happened, which meant that my output didn't get changed correctly. Let's go look at the code and see what's happening there. I did an open, and then I change it to go to the checkout. I see what's wrong. Instead of a load A, that needs to be load X. So let's modify that to be load X and logical file 4. Now let's try it. That looks better. My hello world went somewhere. We'll have to go to the disk and check it out. Before we leave, I'd like to point out we've added a stack display for debugging, and we've added the 0-page register displays for debugging. When you hit a break instruction, the debugger will populate all of these boxes with state information that's useful to debug your program. All right, let's go check out that file. So I just quit the emulator, and it's time to open up the SD card and see if we got the output we expect. I'm on a Macintosh OS X, so my method of opening the SD card will be different than you might be if you're on a Windows or a Linux machine. My operating system will open it up as if it's a mounted disk, and when I look in here, there's the assembly environment. And here is the file that we wrote. I'll double click on it, we'll get the text. Let me blow this up so you can actually see what's going on here. And sure enough, there's the text that was in our assembly language program. Hello World file version. Cool. Let me point out that in our program, if I had opened the file name with these attributes, sequence, RAID, and then instead of using the output character routines, I use the input character routines, I could actually read data from the file on the SD card. And I've tested that. That works fine and dandy. My understanding is there will be an append mode coming along in a future version of the kernel. I haven't had a chance to test it. I don't think it's in there yet. I should also point out that there's a couple of things you should be aware of. I don't recommend having the disk image mounted while you're running the test program because there's some confusion between the host operating system and the emulator about who gets permission to write files, and so your results will be unpredictable. I really suggest you don't have it mounted when you're running your program. If you're ready to give this version of the assembly environment a try, head on over to the home page listed here. There, you'll find documentation about the assembly environment as well as a zip file so that you can install it and try it yourself on your own emulator. Hey, thanks for watching. Happy coding. Stay safe. We'll talk to you later.